Today's video takes us a little bit more in depth with histograms. After today's presentation, we should be able to construct a histogram from a data set and also describe a histogram based on its spread, outlier, center, and shape. Just a reminder here of the definition of what a histogram is. It displays numerical variables in classes and shows only the percent of the observations that fall into each class, or it could be the count of observations also, as we're going to see. And the only time that a histogram has a space in between is if a class is empty, meaning there is no count there or no percentage of things represented within that class. Today we're going to construct a histogram based on this data set. We have IQ scores for 60 randomly chosen 5th grade students, and those scores range from 81 being the lowest to 145 at the highest. The first step in constructing a histogram is to divide the range into classes of equal width. Now ours range from 81 to 145 as we previously discussed, and a good rule of thumb for determining the number of classes is to take the square root of the number of data sets that you have. So n is the number of data sets that you have. So in our case we had 60 data values, and so we would take the square root of 60, which gives us approximately 7.7, and then we round that up, and so we'll have 8 total classes. And even if that had been 7.1, we would still round up to get our classes that we should have. And so we're going to have 7 classes, and if you take our range and subtract 145 minus 81, you get 64. And 64 divided by 8 would give us a width of 8, but just for the sake of having nice numbers, I'm going to do by 5s. So we're going to do a width of 10, and our classes, we're going to have 8 classes as we discussed. So we're going to go 75 for the first class to begin with, and then that's going to go all the way until 85. Now if you noticed, I use equal to here and not equal to here. And that's because our next class is going to start with 85, and we don't want to have a class that has 85 in it. We don't want to have a class that has 85 in it and then another class that also has 85. So our second class would start with 85, and it would include all the IQ scores from 85 until 94. And then you'd have your next class starting at, not 94, 95. And so on and so forth. So we do that until we get our 8 classes that we're trying to create. And we're going to see that in the chart on the next slide. So here we have our frequency table, as it's called, and we're going to talk more about this week. And we have our classes listed. Now notice when I listed them here, instead of using interval notation like I did here, I'm just doing it in this manner, 75 to 84, and I don't have 75 to 85 because 85 is in the next class. So I don't want to include it here. So the second step when constructing our histogram is to find the count or frequency of individuals in each class. And then we're also going to find the percent, which is called the relative frequency of individuals in each class. And we're going to construct 2 histograms based on that data. Relative frequency is helpful when you are comparing distributions with different numbers of observations. So for instance, if I was comparing the scores that we have to the scores of another 5th grade group from a different year, but in that group I had 80 scores instead of 60, relative frequency would be more beneficial then when I'm comparing those two as opposed to just the counts or the frequency, because we have a different total number of scores. So by creating that percentage, it makes the 2 data sets more comparable. To get the number of counts within this class, I would have to go back to my data set on the couple slides before where I had all the scores and count the number that are in the range from 75 to 84. And when I do that, I get a count of 2. When I do it for the next class, I get 3. The next is 10, 16, and then moving to this class on the right, we have 13, 10, 5, and 1. And now when I add up all my counts, I should get 60 because that's the total number of data that I had. Now to get the percent, I'm going to take the count and divide it by the total number of data sets, which in our case is 60, and then multiply by 100 for the percent. So I'll just write this first one out so that you can see. If I'm going to get the percent for the very first class here, I would take 2 divided by 60 and multiply that by 100, and I get approximately 3.33%. And I'm going to round each percent to the nearest percent. So I would do this one as 3%. The next one I do that same process, I get 5%. This one's 17%, 27%, 22, 17 again, 8, and 2. And when I add up all the percents, I should get close to 100%. When I add these up, I get 101%, which is just because we rounded, and that's considered rounding error, and that's acceptable as long as you don't get like 115%. You don't want to be off by much. You want to be within 1% or so, plus or minus. And now using our chart, we're going to make 2 histograms with this data. One's going to be using the count, and the other's going to be using the percent. And this is just that chart filled in nicely without my handwriting all over it. And this little dot 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 that you see when I transferred this file over from PowerPoint into my app, my little dot 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 moved there, so I apologize for that. Alright, so we're at step 3, and this just gives us some guidelines when creating a histogram for you to look back on. You always want to label and scale your axes before you draw it. The horizontal axis is going to be the one where you have your classes, and our scale for that axis is going to go from 75 to 154 in this case, because that's where our classes fit. The vertical axis is going to contain your counts or your percents, depending on if you're using the frequency or relative frequency. The base of the bar is going to cover the entire class. So our first bar, when you see our histogram, is going to go from 75 all the way until 85, where the other class begins. And then the bar height is how we'll follow up until that class frequency. And as we said when we began, there's not going to be a space unless there's an empty class. And in our case, there will be no spaces because there is no empty class in our histogram. Okay, so here's our histogram when we're using the frequency, also known as the counts. And again, I apologize, this number of students is supposed to be within this text box, and it messed up when I transferred the file. But as you can see, I've labeled this axis IQ scores for 5th grade students, and this is their range of scores, our classes, 75 to 85, 85 to 95, and so forth. And over here is the number of students that fall into each of those classes. So if I'm looking at the first class, I know that 2 students out of the 60 are falling within this class. If I look at this class over here, the class of scores from 125 to 135, I know that, looking from here, 10 students fall within that range of classes, or that range of scores, excuse me. Now remember, as we learned last week, we want to describe our distribution based on the spread and outlier if there is one, the center, and the shape. So we always describe a distribution using this SOX acronym. Spread, outlier, center, and shape. And so if we're looking at our histogram, when I'm talking about the spread, I'm just going to say something about the range of scores. And our range of scores is from 75 to 155. And for outlier, I'm going to say there is no apparent outlier because there is nothing that is very far from the center or from any of the data points. when talking about the center, I'm going to say that the center of this distribution is right around in here somewhere within this bar class. So I'm going to say that the center is around 110. And the last one is the shape. Remember, the shape can be skewed right or left. It can be symmetrical. It can be bimodal or unimodal. And so for this distribution, I'm going to say that it's roughly symmetric. You could also say that it is unimodal because it has one peak. And so that would be how I would describe this graph. And it's very important for us to remember this acronym because that will probably be a free response question on the AP exam, or at least part of one is describing a distribution using these 4 aspects. And now this histogram differs from the first one in that it uses the percentages or the relative frequency. And so this is the only thing that changed over here. Instead of counts, we have percentages, as our axis says. And it's roughly the same for the size of the, or I guess I should say height. The height is roughly the same for the bars in our histogram. The classes are exactly the same in our histogram. And so how I could read this one is if I'm looking at, let's say, this first class, I would say roughly 3% of the 60 students scored within 75 to 85 on their IQ test. We will have a test next week. Part of it's multiple choice and part of it is free response, just like the AP exam will be in the spring. And I promise not to do this to you.